A very good day to everyone. I am Philomena Arakyasamy. Today I would like to present my research entitled Bifunctional Geopolymer Adsorbent to treat copper ions and ciprofloxacin from wastewater. This presentation includes introduction, problem statement, objective, literature review, followed by research methodology, significant finding, knowledge contribution and fundamental research of the study, novelty, conclusion, journal publication, and also appreciation. Copper ions is one of the most hazardous heavy metal. It is largely produced in the industries such as tire, fertilizer, paperboard, metal cleaning, and also washing sector. Copper also widely employed as a feed addition in the livestock. So, copper commonly coexists with antibiotics such as ciprofloxacin, which is most commonly prescribed and consumed broad-spectrum antibiotic. However, the functional group of ciprofloxacin allows it to connect with other chemicals, for example, heavy metal ions, to form metal antibiotic complex, resulting in a complicated removal process. In this regard, adsorption is ease of use, low cost, as high removal efficiency of pollutants, and as high capacity for regeneration. Among various types of adsorbents, geopolymer is currently receiving a great demand in wastewater treatment application because of their porous nature, large ion exchangeability, low cost, various functional groups, and also structural flexibility. So the problem statement of this study is, in the co-adsorption of copper ions and ciprofloxacin, most of the adsorbents show limited adsorption sites, especially with increasing copper concentration. Therefore, hydroxyapatite was planned to be incorporated in the geopolymer structure as it contains two distinct types of charge active sites on its surface, namely cationic calcium magnesium and anionic phosphate and carbonate. So the objective of this study is to investigate the optimum filler loading of hydroxyapatite into geopolymer made of metakaolin and sludge particles for the simultaneous adsorption of copper ions and ciprofloxacin. Based on the literature review conducted, most of the geopolymer was synthesized by using raw materials such as fly ash, slag, foundry dust, metakaolin, and many more, while there is no study on hydroxyapatite geopolymer. Besides, the synthesized geopolymer has been focused in the removal of heavy metal or antibiotic. However, there is no study on the simultaneous adsorption of heavy metal and antibiotic. So this is the significance of this study. For research methodology, it starts with mixing of raw materials such as metakaolin, sludge, and hydroxyapatite with alkali activator. Then the obtained geopolymer paste was oven cured at 60 degrees Celsius. After that, the hardened geopolymer was crushed into powder particles to be directly applied in the adsorption process. After adsorption, the concentration and removal efficiency of copper and ciprofloxacin was measured by AAS and UVVs respectively. For characterization, the synthesized geopolymer was characterized by XRD, FTIR, BET, and EDX. Now let's look into the result and discussions. Based on the phase analysis, In addition to acrylonite and anorthite, additionally berlinite and calcite was formed with the incorporation of 2% of hydroxyapatite. Thus, at 2% of hydroxyapatite, the functional moieties such as alumina, silica, phosphate, carbonate, and cations such as calcium and magnesium that are exposed for ciprofloxacin and copper adsorption increase. Besides, based on the functional group analysis, the main adsorption band of geopolymer at 1029 was shifted to 987, indicating the accelerated geopolymerization, providing more functional groups and cations for the adsorption process. In addition, with the incorporation of 2% of hydroxyapatite, the pore size distribution of geopolymer exhibit a broader size in the range between 5 to 42 nanometer, highlighting a more mesophorous structure has been formed. The mesophorous structure is beneficial for the adsorption process as it reduces the penetration resistance during adsorption. Besides, the mesophorous structure also highlighting a high degree of reaction of geopolymerization consistent with the FTIR analysis. Now let's look into the removal efficiency of copper and ciprofloxacin in both single and binary system. The removal efficiency of ciprofloxacin is first increased with increasing hydroxyapatite particle up to 2%, while this was further improved in the binary system due to the cation bridging effect and complexion. However, the removal efficiency of copper remained the same as it was not affected by the hydroxyapatite particles. After adsorption, elemental mapping and also elemental composition was conducted on the geopolymer surface. The distribution of copper, carbon, fluorine and nitrogen, highlighting the successful adsorption of copper and ciprofloxacin on the geopolymer surface. So, the knowledge contribution of the study is adsorption sites can be increased by combining several adsorbents, and the fundamental of the research is hydroxyapatite can increase two distinct types of charge actives on its surface, namely cationic calcium magnesium, anionic phosphate and carbonate. The novelty of this study is hydroxyapatite incorporated geopolymer contribute to increase in the surface functional groups and cations. In conclusion, 2% of hydroxyapatite incorporated into metakaolin/geopolymer result in added functional moieties and divalent cations which improve the removal of copper and ciprofloxacin in the binary system better than a single system. All these papers related to these studies has been published in IPITEX Q1 papers. That's all from me. Thank you very much.